This is Pre-Algebra, Lesson 2, Variables. Now before we begin, we're just going to very briefly review our last lesson on order of operations. So now we learned that when solving complex problems, we have to go through it in cycles, and we have to solve the operators in a particular order. And we can remember this order by using the acronym PEMDAS. And this stands for parentheses, that's the one we do first, and then exponents, and then multiplication and division, and then finally addition and subtraction. So it's a good idea whenever you're solving math equations from now on to start thinking in that framework, because you're going to be using it a lot. Now we also learned how following rules like these enables us to solve complex problems. Math relies on a lot of very strict rules, and it is by following these rules that we are able to get the benefits of using the tool. And we also learned that the order of operations is a very fundamental rule. In fact, everything that follows in this course and all of the other courses after it are going to be coming back to this order of operations. You're going to be using it in all kinds of different problems. Now, thus far, throughout your math courses, you've only been dealing with problems that had just numbers. But sometimes you don't know what a number will be. You might have the equation set up and you know where everything's supposed to go, but you just have one spot and you don't know what it's going to be. You won't know until you get the specific answer from a specific situation. So let's find out how we deal with problems like that.
Let's say that I'm working in a restaurant and I'm making $10 per hour, but on top of my hourly wage, I also get tips each hour. So this entire expression, you can view this as how much I might make in a given hour. Now, you might also realize that the number of tips or the amount of tips I might make in an hour can change dramatically from hour to hour. It can vary. 1 hour, it might be lunchtime, get a lot of tips, people might get some big ticket items. The next hour, I might not have any customers, and then my tips might be really low. So the tips part right over here, we consider that, the entire word, we consider that to be a variable. From scenario to scenario, it can change. So for example, in one scenario, maybe it's lunchtime, I'm getting really big tips. So tips is equal to, let's say it's equal to $30. And so the total amount I might make in that hour is going to, we can go back to this expression right over here. It's going to be 10 plus, instead of writing tips here, I'll write 30 because that's what my tips are in that hour. And so that is going to be equal to, it's going to be equal to 40. Let me do it in that yellow color. It's going to be equal to $40. But let's say right after that, the restaurant slows down. We're out of the lunch hour for whatever reason. Maybe the restaurant next door has a big sale or something. And so the next hour, my tips go down dramatically. My tips go down to $5 for that hour. Now I go back to this expression. The total I make is my hourly wage plus the $5 in tips, plus the $5 in tips, which is equal to $15. As you see, this entire expression, the 10 plus tips, it changed depending on what the value of the variable tips is. Now, you won't see whole words typically used in algebra as variables. We get lazy, and so instead we tend to use just easier to write symbols. And so in this context, instead of writing tips, maybe we could have just written 10 plus t, where t represents the tips that we get in an hour. And so then we would say, okay, what happens when t is equal to 30? Well, if t is equal to 30, then we'd have, so what happens when t is equal to 30? Well, then we have a situation, t is equal to 30. This evaluates to 10 plus 30, which would be 40. What would happen if t is equal to 5? Well, then this would evaluate to 10 plus 5, which is equal to 15. Now, I want to be clear, we didn't even have to use t. We didn't even really have to use a letter, although in traditional algebra you almost do use a letter. We could have written it as 10 plus x, where x is your tips per hour. X might not be as natural. It's not the first letter in the word tips. Or you could have even written 10 plus star, where you could say star represents the number of tips in an hour. But it just might have not made as much intuitive sense. But hopefully this gives you a general idea of just what a variable is. All it is a symbol. All it is a symbol that represents varying values, and that's why we call it a variable.
So we saw that the term variable refers to the unknown part of the problem. Now, variables depend upon context. In other words, you won't actually know what the number is until you get the specific data from a specific situation. And until we have that specific data, we use some kind of symbol to represent the unknown variable. Typically this is letters, although really you can use whatever symbol is appropriate, but letters is the standard practice. And then once you finally have a specific value taken from the specific situation, then you take that number and then you plug it in to the variable place. In other words, you just basically take out the variable and you just put in the real number. Now basically there are two types of values that you're going to see in an expression. The first is called a constant. Now this is the number that stays the same in every scenario. For example, if you're getting paid for your job, let's say you're getting paid $8 an hour. Now the 8 is the constant. That's always going to be 8, no matter what. And then there's the variable. This is the number that changes depending upon the scenario. Now, so let's say, you're still making $8 an hour, so the 8 is the constant, but the number of hours you work could be variable. So you could work 6 hours one day, then 7 hours the next day. You just have to take it scenario by scenario. So now whenever you see an expression that has a variable, here's how you go about solving it. The first thing you have to do is identify the value of the variable. In other words, you have to read about the scenario and get the specific number that it says. Or it might just be indicated to the side, or whatever the case may be, but you have to find out what the value of the variable is in that particular situation. Next, you're going to take that value and you're going to plug it into the expression. You're going to replace the letter, or whatever is used as a placeholder for the variable, and put in a real number. And finally, you're just going to solve using the order of operations as we learned in the previous lesson. So let's take a look at another example of how this works.
A local hospital is holding a raffle as a fundraiser. The individual cost of participating in the raffle is given by the following expression: 5t plus 3, or 5 times t plus 3, where t represents the number of tickets someone purchases. Evaluate the expression when t is equal to 1, t is equal to 8, and t is equal to 10. So let's first take the situation where t is equal to 1. Then this expression right over here becomes, and I'll use that same color, it becomes 5 times 1 plus 3. 5 times 1 plus 3. And we know from order of operations, you do the multiplication before you do the addition. So this will be 5 times 1 is 5 plus 3. And then this is clearly equal to 8. Now let's do it when t is equal to 8. So when t is equal to 8, this expression becomes, and I'll do the same colors again, 5 times 8 plus 3. Plus 3. Same color of green. Plus 3. And once again, 5 times 8 is 40. 40. And then we have the plus 3 there. So this is equal to 43. And so we have the last situation with t is equal to 10. I'll do that in blue. So we have 5 times 10. So 5t is 5 times 10. Instead of a t, we put a 10 there. 5 times 10 plus 3. Plus 3. That's a slightly different shade of green, but I think you get the idea. 5 times 10 is 50. We do 50, and then we're going to have to add 3 to that. And that is equal to 53. And we're done.
Okay, so we get the basic idea of how variable expressions work. But what about for those times when we see exponents in the equation? Now sometimes when we see the exponents, they can look kind of scary and we shut down our mind. But really there's no need to be alarmed, because exponential expressions, though they look more difficult, they really use the same process. All you're going to be doing is apply the order of operations as we learned in the last lesson. And it's really the same process. It just looks harder. So let's see an example.
Evaluate the expression 4n to the first power minus 2n to the 0th power for n equals 1 and n equals 5. So let's do n equals 1 first. So every place we see an n, let's put a 1 in there. So this is equal to 4 times 1 to the first power minus 2 times 1 to the 0 power. Every place we saw an n, we have an n there. We have an n to the first, n to the first, 1 to the first. So remember, we want to do our order of operations. We have PEMDAS, and I'm going to write it this way just to make it clear that we do parentheses, then exponentiation, then multiplication and division are at the same level. They get the same priority. And then addition and subtraction get the same priority. So we want to do our exponents before we do anything else. There are no parentheses here. So we first want to evaluate 1 to the first power. And anything to the first power is just that anything. If I just have any number to the first power, that is just going to be equal to that number. So 1 to the first power is just equal to 1. So this is going to be 4 times 1. Let me write it. 4 times 1 minus 2 times 1 to the 0th power. Now, any number other than 0 to the 0th power is going to be 1. So if I tell you x to the 0th power is equal to what? And I tell you that x is not equal to 0. What is x to the 0th power? You should immediately know that it is equal to 1. I exclude 0 because 0 to the 0th power is usually undefined. Or for our purposes, you can accept it to be undefined. And maybe in the future, I'll do a video on explaining why it's undefined. Because it could either, there's some good arguments for why this should be 0, because 0 to pretty much any other power is 0. But then there's a really good argument for why it should be 1, because any other number to the 0th power is 1. So that's why, for the most part, we like to keep this undefined. So with that said, 1 to the 0th power is just going to be 1. Anything other than 0 to the 0th power is 1. So we have 4 times 1, which is 4, minus 2 times 1, which is 2. So 4 minus 2 is just equal to 2. Now let's do the same thing with n equals 5. So it becomes 4 times 5 to the first power minus 2 times 5 to the 0th power. Same thing. 5 to the first power is just going to be equal to 5. So let me do that I want to do that in a different color. 5 to the first power is just going to be equal to 5. 5 to the 0th power is just going to be equal to 1. And so this expression becomes 4 times 5 minus 2 times 1. Or 4 times 5 is 20, minus 2 times 1, that is 2. And this is equal to 18. And we're done.
So now that we understand how to solve variable expressions, let's think of some common examples where we might use variables in everyday life. Perhaps one of the most common is hourly wages. Now in this case, you will probably be getting paid a certain amount per hour. So you might get paid, $10 an hour, but the total amount of money that you make will be dependent upon the number of hours that you work, and that could be variable from day to day or week to week. And so in this case, the wage is constant, but the hours are variable. Another example is average points scored in a season. So let's say you're playing a sport and you know the exact number of games that you're going to play that season. And you also know the equation on how to get the average score. You know how to calculate it. But what you don't know is how many points you're actually going to score that season. That will be variable from season to season. And another area where variables are used a lot is computer programming. If you ever get into that, you'll discover that it really is impossible to write a functional computer program without a variable. And the reason for that is because you can tell the computer what you want it to do, but it won't be able to have a meaningful interaction with the user unless it has a variable, and that's because it doesn't know what the user is going to type in. So all of that has to be a variable. So in conclusion, remember that variables are what we use when context matters. In other words, you have a part of the equation where you don't know what the number is going to be until you get the data from a specific situation. And variables are paired with constant numbers. The constant numbers are the part of the equation where the number is always the same from situation to situation. And finally, remember that variable expressions, though they look different, are solved just like any other expression. We're going to use the order of operations, or PEMDAS, as we learned in the previous lesson. And you're just going to go through that process and solve it like you would any other expression. So understanding this concept of variables is going to open up a lot of new possibilities for you in your math studies. I think you're going to enjoy it.